All you college and high school students out there, has your thought process ever trailed off in calculus class and you thought, who created this abomination and why even? No? Yeah, me neither. Because I don't want to make a project about the applications of calculus and the connections of calculus to our universe or something like that.
Hello there.
You guys are getting this. Our journey starts back in the 4th century BC, when Greek mathematician Eudoxus used something called the method of exhaustion to determine the areas and volumes of shapes. The method of exhaustion is basically splitting a polygon up into triangles. The Greeks knew that the amount of triangles in every polygon was 2 less than the amount of sides it had. Using this, Eudoxus could easily connect the vertices of a polygon to form the triangles and get their areas. A few centuries later, Archimedes built upon the method of exhaustion by using it to prove the area of a circle equal to pi r squared. He did this by inscribing a polygon into a circle and increasing the number of sides each time until he determined that the number of sides needed was infinite. In a way, he had unintentionally developed the concept of what we now call limits. Archimedes' form of the method of exhaustion is called heuristics. Heuristics is a form of problem solving that resembles early forms of integral calculus. Archimedes used it further to determine the area under a parabola and the surface area and volume of a sphere. Jumping to the 17th century, we come to the scientific revolution, where there's so much knowledge and discovery, it makes that knowledge meme guy proud.
Knowledge.
Isaac Newton, who I assume all of you know, lived during this period. In 1661, he attended Trinity College in Cambridge. However, after he graduated in 1665, he was forced to go home to Lincolnshire to escape the horrors of the bubonic plague in London. Sounds familiar, right? Like something that happened about a year ago. COVID-19 aside, Newton was in for one hell of a quarantine isolation. During his time at home, the man indirectly co-invented calculus, very controversial that I'll discuss later on in the video, discovered the laws of gravity and motion, and he started to develop the theories of light and colors and how white light is made out of 7 colors, basically the rainbow. And all I did in quarantine was attend online school, sulk in my sorrows, watch TikToks, and play Minecraft. The contrast really is daunting, to be honest. I envy this man. So while London was getting engulfed in flames and people were dying all across Europe because, you know, plague and all that, Newton was revolutionizing mathematics and physics. The reason Newton actually invented calculus was out of necessity. He needed it to solve something related to physics. He wanted to calculate the exact velocity of an object at a particular instant in time. The mathematics for that hadn't been created yet, so he went all Thanos on us.
Fine. I'll do it myself.
Newton approached it like this. He knew that you could get the slope on a velocity time graph easily by doing rise over run. But there was no way to calculate the given slope on a curve that was frequently changing its rate at the time. Newton realized that as the secant of a curve became smaller and smaller, it would eventually become a point on the line that you could draw a tangent line through. So as the slope of the secant approached 0 over 0, aka its limit, it would also approach the exact slope at the tangent point. Newton had just found out how to calculate the derivative. He called this process of calculation the fluxion, and he called the varying x and y values on a curved line the fluents. The fluxion is basically the differential calculus we use today. He later discovered that the inverse of differentiation was integration, and he called that the method of fluents. Integration is known as the area under a curve, and is very similar to what Archimedes did with heuristics and the method of exhaustion for the circle. Instead of infinitely sided polygons, however, for integration, you create infinitely smaller rectangles under a curve to calculate their area, then add it all up to get the area under a curve. He went on to publish his findings and much more in his book Principia Mathematica in 1687, which actually almost didn't get published because of a book about fish. Nemo and his aquatic gang of marine life almost deprived the world of the book that had Newton's stuff about physics and calculus that literally took humans to the moon. Now on to the next European boy, this one coming from Leipzig, Germany. Around the same time when Newton was doing his physics and mathematical discoveries, Gottfried Leibniz had only dabbled in the fields of philosophy and law, until he met his friend and mathematician Christian Huygens, who convinced him to give math a try. Leibniz not only gave it a try, but the man quite literally became the only other person in the world to invent the revolutionary form of mathematics known as calculus. He was the one who came up with the idea that the area under a curve could be calculated using infinitely smaller rectangles. You know, the one that I mentioned earlier about integration. Basically, he determined that integration was just the sum of infinitely tiny distances, and identified that differentiation was the inverse. The notations that we use nowadays in calculus, yes, the ones that are making your calculus class a nightmare, are the ones that Leibniz created, not the ones that Newton created. Now, while both of these guys heavily revolutionized mathematics, there's a debate that's been going on since the 17th century on who is the original discoverer of calculus. Eventually, Newton was deemed the first discoverer, even though Leibniz was the first publisher, because at the time, Newton was the president of the Royal Society, aka the leading publisher of scientific books in that era, and the one that made all the decisions relating to science. So technically it was a bit biased, because Newton was the president and all, but in my opinion, I honestly don't care who the first discoverer was, because both made huge contributions that it doesn't really matter who was the first. On the other hand though, I'm Team Leibniz in a way, primarily because the whole debate was, as I said, one-sided and biased, and the Royal Society are a bunch of